Lucas. Why? Me why? I haven't got paid.
All right, today we are going to start the next chapter.
9.5 hours.
I am. Okay. The next chapter is all about transformations. Okay.
It was the hours that you said.
A transformation is just an operation that takes some original figure, and we call that original figure the pre-image. Okay. Onto a new figure called the image. Okay. Pre-image onto the image. Okay, so a transformation can change the size, position, or we're going to say orientation. Okay, now in this chapter, we are actually only going to look at ones that change the position and orientation. Okay, in this chapter, we are not going to look at ones that change the size. Okay? We're only going to look at ones that change the position and orientation. Later on in the year, we'll look at transformations that change the size of a figure. But everything we do in this chapter, the size of the figures are going to stay exactly the same. So the first transformation that we're going to look at today is reflections. Okay? So a reflection is just a flip over a line. And we call that line the line of reflection. Now, the key is that each point and its image are the exact same distance from the line of reflection. Okay? And we'll take a look at what that means here in just a second. So the possible lines of reflection that we're going to use, okay, we're going to reflect in both axes, so the x-axis and the y-axis. We're going to reflect in other vertical and horizontal lines. Okay? And we talked about what those look like. Okay? Like x equals some number. Okay? We could call that number like A. And then y equals a number. Say y equals B. And then ones that we're going to look at tomorrow. Okay? So these are the ones we're going to do today. And then tomorrow, we'll look at lines like y equals x. And y equals negative x, okay, reflecting across lines like that. So let's jump into a couple of examples. All right.
Kevin, I see what you think about putting that back. What up, AA? You don't like you, Mr. Green.
What did you say?
I said he don't like you.
That's me.
I don't care.
So on these first two examples, I'm reflecting in axes. Okay, the x-axis and the y-axis. So we're going to do 1 and 2 together, then I'm going to have you guys try 3 and 4, all right? So on number 1, we're taking this triangle with vertices A, B, and C. So let's plot those points first, our original points. So I'm at the point -4, 2, that's A. Then B is at 4, 1, 2, 3, 4, 5, 6, 7. So B is up here. And then C is at the point 5, 1. So this is my original triangle. And I want to take this and reflect it in the x-axis. So which one is the x-axis? This one or this one? The horizontal one, right? So it may help, just to remind yourself to label the axes X and Y. So I want to take this figure and reflect it across the x-axis. To do that, I'm going to take each point individually. So let's start with A, and I'm just going to count the distance to the x-axis. That's my line of reflection. So I'm just going to count 1, 2. Then I'm going to go that same distance on the other side of the x-axis. So I'm going to count 1, 2. And that's where my reflection of A will be. To label our new point, I'm going to put a little apostrophe on it. It's called a prime. We're going to call it A prime. Okay? So I'm going to do that same thing with each of my points. So now if I go to B and I count the distance straight down to the x-axis, I'm going to go 1, 2, 3, 4, 5, 6, 7. So then across the x-axis, I'm going to go 1, 2, 3, 4, 5, 6, 7. And I'm going to label that point B prime. Okay? This looks like a little apostrophe. Same thing for C. So to get from C to the x-axis, it's just the distance of 1. So then I go that same distance on the other side. And we'll label that C prime. So then I can connect my coordinates. And this is a reflection across the x-axis. So if I were to fold my paper across the x-axis, these two figures would sit on top of each other. Right? So then we want to write what our new coordinate points are. So my A prime, I'm at -4, -2. My B prime, I'm at 4, -7. My C prime, I'm at 5, -1. Right. Very similar idea if I want to reflect across the y-axis. And I just want to take my figure and flip it across the vertical axis. Right? This is my y-axis. This is my x-axis. So again, let's start by plotting the original figure. So P is at 1, 2. Q is at 2, 5. R is at 8, 3. And S is at 7, 0. So here is my original figure. And I want to take this and reflect it across the y-axis. Okay, so it's going to come over here this time. So again, I just want to count the distance from each point to the line of reflection. The y-axis is my line of reflection. So we start with P. P is a distance of 1 from the y-axis. So I'm going to go a distance of 1 onto the other side. That's my P prime. Q is 1, 2 away. So I'm going to go 1, 2 to get to Q prime. R is 1, 2, 3, 4, 5, 6, 7, 8 away. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 to get to R prime. And then finally S, 1, 2, 3, 4, 5, 6, 7. Then 1, 2, 3, 4, 5, 6, 7. That's where my S prime will be. So here is my reflection of this rectangle in the y-axis. So again, write down our new points here. So P prime is at -1, 2. Q prime is at -2, 5. R prime, bless you, is at -8, 3. And S prime is at -7, 0. Right, so for these reflections, all we're doing is taking each individual point and counting the distance it is from the line of reflection, and going that same distance on the other side. Okay? Questions?
Yeah, I did that wrong. I'll put it underneath it again.
Yeah, so this one, we were going across the y-axis.
Oh, okay.
This one across the x-axis.
I just need to finish reading very quick.
Okay, so let's take a few minutes and you guys tried 3 and 4. Okay, and number 3, I'm reflecting across the y-axis, and number 4, I'm reflecting across the x-axis. Okay, so give these a try here.
You better not cough like that because you're going to start.
Alright, let's take a look up here. Here are what numbers 3 and 4 should look like. Okay, if I took my original trapezoid, which would have been right here, and reflected over the y-axis, I would end up over here. Okay, now the one thing that may have been a little weird on this one is that we had one point that was actually on the line of reflection. So its distance to the line of reflection is 0. When I reflect that across the line, it's going to be in the same spot. Right? That'd be like if you put your nose up to a mirror. Right? The distance between your nose and the reflection of your nose is nothing. Right? They're right on top of each other. They're at the same place. So reflecting something that's already on the line of reflection, it'll just stay in the same spot.
Depends if it's
Right?
one way here or not.
Then number 4, flipping across the x-axis,
Right?
we should end up with something like
one way here.
this.
You'll have a gap.
Right? Questions on those? Feel okay with reflections so far? I did also see a few people as I was walking around mix up coordinates. Okay, so they plotted -5, -2 backwards. If you don't remember how to plot coordinates or it trips you up a little bit, use Desmos. Okay, type them into Desmos and see exactly where they should be. Okay, I'm actually going to do the next couple, show you how to use Desmos to do that. Okay, so on the back then.
Well, this was easy.
Good, I'm glad. On the back, we are going to reflect in horizontal and vertical lines other than the x and y axis. Okay, so if I take a look at number 5 here, it tells me I want to reflect this triangle, okay, with coordinates j, k, and l in the line x equals 4. Okay, so first let's just plot these coordinates. So j is at 1, -1.
You just had to make it more confusing, didn't you?
Well, I think we got the first part down pretty easy,
You
so
shouldn't have did that yet.
let's get a little bit more advanced.
That's why.
Okay, so here is my original triangle,
Gauge
right?
degrees.
JKL. I want to take this and reflect in the line x equals 4. What does the line x equals 4 look like?
I don't know.
So what this tells me is that the x coordinate of every single point on my line should be 4. So I want to go to where x is equal to 4. So that would be here. So this is the point 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. So the line x equals 4 is actually a vertical line, like this. Okay? Now, if you don't remember that, okay, if that trips you up, use Desmos. Okay? Set up the original problem on Desmos. So if I go to Desmos and type in my given information, okay, which was the points, thank you, 1, -1, 3, -2, and 2, 3. Oops, froze a little bit. Okay, and then we can type in the line. Come on. Why did it freeze? You want the power to go out? Why did this freeze? There we go.
What's that, bud?
And then, what was the other one? 2, 3.
Powder.
Okay, so 3 points to get my original triangle, and then type in the line that we want to reflect across. So I'm in x equals 4, and it'll give me that vertical line. Okay, so if for any of these, okay, you get tripped up on how to set up the problem, type it into Desmos. That'll give you the original problem. Right? So here are my 3 coordinates. Here's the line I want to reflect across. So I'm going to do the exact same thing as we just did. I'm going to count the distance from each point to the line of reflection. In this case, my line of reflection is this green line, x equals 4. Okay? So I'm just going to count that distance. So 1, 2. So I'm going to go another 1, 2. Count the distance. 1, 2, 3. So I'm going to go 1, 2, 3. Thank you. Count the distance. 1. So I go another 1. So here is where my reflection would be. Okay. So if you can do this by hand, that's perfectly fine. You don't have to use Desmos. But if you forget what these lines look like, or if you're getting tripped up on how to plot points, use Desmos. Okay, so let me redraw this over here. So here is where my new triangle would be. So if we fill in those coordinate points, let's see, J prime is at 7, -1.
6, 3, and 5, negative.
6, 3, and 5, -2. Yep.
So if I look at a mirror, will I be upside down?
We feel okay with something like that?
Yeah.
Okay, so you guys try number 6. Okay, it's the same idea. We're reflecting in the vertical equals -1.
Is it okay if I use like a different colored pen for the line?
Sure. Yeah, absolutely. Yeah, use whatever colors you want for your notes, for tests, for whatever. Yeah.
Hey, come here. Hey.
What?
Every time I tell him to come here, he goes somewhere else. Go book a bubble.
Oh.
Damn, digging in his head.
They're fat!
Listen,
I've called
he
your
called
name
you and you
like
walked
6
away.
times.
He's like, every time I call him, he walks somewhere else.
Listen, I was asking if I turn a mirror sideways, will I be upside down?
Wait, if you turn what side?
A mirror sideways, will I be upside down? It's the x-axis.
How do you turn your sideways?
Like, if you take a mirror and it's like this, it's like a rectangle. If you turn it sideways, it'd be the x-axis, and you'd be upside down, right?
Oh my gosh, it's not quite years.
The reflection would be upside down. I'd be standing on the ceiling. Man, I'm smarter than you. That's why you're mad.
What? Hey, listen.
What? Why?
She's gone until I think the 17th.
Why?
She's gone.
Oh. By yourself?
With Jim.
Oh.
So we got the house to ourselves.
Ah! Hey! That's not right. You're not doing it right. You're not doing it right.
I'm not doing it right.
No, R says 0 first.
Yeah, 0. The first number is how far left.
Listen, I didn't even like. Shut up.
You ever heard? You don't remember the term "run then jump"?
You run and jump. I jump then run.
Why do you jump then run?
I don't know. Ask you. Someone beeps a horn out, I'll jump and then I'll run.
Well, yeah.
See, exactly. Be smarter than
That's
yourself.
in a different situation. Why do you just jump and then run? So in gym class, when you have to run, you just jump in the air and then take off running?
Yeah. You don't like my style?
No. Pretty well.
Try it once.
I think I'll pass.
Oh my god. We were messed up. My phone was going off and Gavin, like, Moses pulled it out and looked at it.
I see it's connecting.
No, it says nigga G. And he was like, whose phone says N-word G? I was like, mine. He's like, who's N-word G? I was like, that's Big God's.
Well, I have to admit, like, I looked up
What does Tom say?
I don't think she heard him. But he came over, he was like, who is it? I was like, it's Huge Cause. And I was like, so if it says nigga B, it's Brayden, and if it says nigga D, it's Dustin. He's like, everybody's name in your phone start with the N-word? I was like, no, just those three.
Just those two. Right, just those two.
1, 3, 4, 5.
Oh, not bad. It's really long. 1, 3, 4, 5. That's only 4 problems.
Look at this dude over here. This dude.
Well, I thought about it.
No, you get me right.
Did you just stare at him? Were you just staring at him?
I still need it.
Okay, so did we get something like this for number 6?
Listen, I just.
Okay, so my original square was over here,
You're about to get it.
RSTU. Then the line x equals -1 is right here.
Don't talk to this guy.
So I'm just counting the distance from each point to the line of reflection, and then going that same distance on the other side.
You better knock off.
Okay, so my reflection should end up over here.
No, you did it wrong.
Why is that one
You did it wrong.
I did it wrong.
Yep.
Where did I mess up?
I don't know. I'll let you know. Listen. Never mind. Wait, I'm not done.
Yeah, say happy home.
Okay, you can go now.
Alright. So then the last idea that we're going to look at today is 7 and 8, reflecting across a horizontal line other than the y-axis. So if I look at number 7,
Hey, no. Not the numbers, not the numbers.
Negative. Yeah, I got him. Good. He can erase them.
alright, if I look at number 7 here,
I got it, Holmes. -8, -1, -3, -2. Okay, you're good.
alright, this one, I want to take these 4 points and reflect in the line y equals 2. So what this is saying, it is go to where every y coordinate is 2. So the y coordinates, okay, where every y coordinate is 2 would be here, right here is 0, 2, 1, 2, 2, 2, 3, 2, 4, 2. So that would be this horizontal line here at y equals 2. Now again, remember, if you don't know what that looks like, type it into Desmos. Get a picture of the original problem using Desmos. So then I'm taking my original coordinates are -4, -4, -2, 0, 6, 1, E, and then 4, -3. So here is my original figure.
No.
And I just want to take this and reflect it across this line now. So I'm just counting the distance, okay, for each individual point. So if we start with D, thank you. That's 1, 2 away, so I'm going to go another 1, 2 to get to D prime. E is just 1 away, so I'll go another 1 up there.
Move your hand.
F is 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5 to get to F prime. And then C, 1, 2, 3, 4, 5, 6, so 1, 2, 3, 4, 5, 6 gets me to C prime. So here is where this reflection would end up. Okay, so then just write in those new coordinates. So let's see, C prime will be at -4, 8. D prime is at -3, 4. Or no, sorry, -2, 4. E prime is at 6, 3. And F prime will end up at
Wow.
4, 7.
No, like she. Never mind.
Okay, so we should be able to visualize that, if we folded our paper in half, it would end up, these two figures would end up on top of each other if I'm folding across that line of reflection. Okay, so go ahead and try number 8 here. Okay.
Listen.
Plot our 3 points and reflect in the line y equals -5.
I feel like Mr. Haynes
How
He
is
goes through like 8 lessons in
Yeah,
3
he goes
minutes.
through like 2 lessons a day. I'm not complaining.
No, I meant like Mr. Haynes goes way too fast.
He goes way too fast.
Well, if I'm going too fast, just
No.
tell me to slow down.
You're good.
Yeah,
I'm talking
you're
about
good.
him. Like you need to go over there and smack him somehow.
Yeah. Tell him how to rock. Teach him how to rock a man bun, and then smack him. Give him one. Say, "You freaking want one, Ricky?" And when he back talks, just freaking lay one on him. Just freaking lay it.
Like
on
he doesn't ask questions for nothing. It's like he's
Yeah.
going. Like he does his own. Like he'll do his own thing the whole time until everything's over and then he'll erase it. It just makes you want to throw the table at us. What is wrong with you? You stupid. I'm about to throw a table at him. I already shot him with a hornet.
You almost shot me with a hornet standing at the board. Oh, listen, Mr. Williams almost got one of these thrown at him today.
What?
One of these things.
What?
This one says line wide.
Because listen, I'm sitting on that couch in the front, on the far left one against the wall,
Mhm.
and I'm sitting there and I was like, Mr. Williams,
We've already done.
Mr. Williams, I said it 2 or 3 times, like loud. He didn't hear me. He kept walking away, and I was
Yeah, I've got another
just picked it up and throw it at him.
The stuff that
Well, I
we
does it.
We have anger issues sometimes.
Sometimes I
Well, you're always retarded, so.
No, I
That's correct,
have-
right?
Dude, this blister on my dog is good.
What?
Yeah, you mind if I use your that's one?
Lick it. Bite it. Did you even work on your bike last time?
Yeah, I did.
What'd
Like
you do?
midnight.
What'd you do?
I took Nate's battery off, tried putting it on mine, but the battery was dead, and I don't have anything to dump the battery. And but the carb was on it, but I don't know what else I can do with it. What can I do with it? There's nothing to do.
You just put the gas tank on.
I took the gas tank off.
That's the way to put that on, put gas in it, and try to use your petcock.
Literally, dude. You know that elbow, that 90 degree that comes out of the petcock?
Yeah.
Yeah, that whole thing just pulls out. And it's so tight.
We gotta try it somehow.
We're gonna
We gotta
zip
get
tie
fuel
back
into
on.
that carb somehow.
I know. We can zip tie
Listen,
back.
you're in the way.
I'm purposefully in the way because I want you to do this one on your own.
No, I was just trying to figure
Why
out
did you put the answers in?
the line.
Oh, one
You need to get like a magnetic board that's not that doesn't like
Oh, I got
touch completely to the board, so you can cover answers, or something like slides across the top.
Yeah, that'd be nice.
Up one. Over one. Up two.
Now for this one, y equals the number is on the horizontal line. So that'll be right through here. Y equals -5. So y equals is always horizontal. X equals is always vertical. And if you forget that, just type it in your decimal and see what it looks like. Okay, so for number 8, okay, I think we should end up with something that looks like this. Okay, our original figure was down here. Okay, so if I reflect that across the line y equals -5, it's going to end up here. Okay. I've got a few problems for you guys to practice for homework here.
They're supposed to have 24-hour queue time. Sitting on the jack still like this. I've known that they drive a 24-hour clock.